Imagine a vast empty stage. Darkness surrounds you. Suddenly, a beam of light cuts through the void. In its shimmering embrace, a three-dimensional object appears, seemingly solid, tangible, real. But here's the twist. It's all an illusion. This object you see is a hologram, a projection from a two-dimensional source. Now, what if I told you our universe might be the grandest hologram of them all? This might sound like something straight out of science fiction, but stick with me. The idea that our reality is a hologram, projected from information encoded on a distant two-dimensional surface, has captivated physicists and philosophers alike. It challenges everything we thought we knew about the universe and our place within it. The holographic principle, as it's called, suggests that the information about everything in our three-dimensional universe, from the smallest particles to the largest galaxies, is actually encoded on a two-dimensional boundary. This boundary could be located at the edge of the observable universe, an unimaginably distant horizon. Think of it like this. Imagine watching a three-dimensional movie on a flat screen. The characters and landscapes appear to have depth and texture, even though the information is actually stored on a two-dimensional surface. Similarly, the holographic principle proposes that our perception of three-dimensional reality might be an illusion, a projection from a lower dimensional source. This idea isn't just a mind-bending thought experiment, it has roots in some of the most complex and intriguing areas of modern physics, including string theory and black hole thermodynamics. It suggests a universe where information, not matter, is fundamental, a universe where reality itself might be more akin to a vast cosmic computer program. One of the most profound questions humans have grappled with for centuries is the nature of reality itself. From ancient philosophers to modern scientists, the quest to understand what is truly real has been a driving force in our intellectual history. What does it mean for something to be real? Is it something tangible we can touch and see? Or is it an abstract concept that exists only in our minds? The holographic principle throws a fascinating curveball into this age-old debate. It suggests that our three-dimensional universe might be a projection of information stored on a distant two-dimensional surface. If our universe is indeed a hologram, then our perception of reality is fundamentally limited by the information encoded on that distant two-dimensional surface. This means that what we perceive as depth and volume might be an illusion. We are like viewers in a cosmic cinema, experiencing a projected reality that is but a pale reflection of the true nature of the universe. Imagine for a moment that you are sitting in a grand cosmic cinema. The screen before you is vast, displaying a stunning three-dimensional movie. The characters and landscapes seem so real, you could almost reach out and touch them. But as you reach out, your hand passes through thin air. You realize that what you see is merely a projection, a play of light and shadows on a flat screen. This is the essence of the holographic principle. It proposes that everything we experience as reality might be akin to this cosmic movie. The depth, the volume, the intricate details, all are projections from a two-dimensional surface far beyond our grasp. Our brains, sophisticated interpreters of sensory information, create the illusion of a fully three-dimensional world from these encoded signals. This perspective challenges our most fundamental assumptions about existence. If the universe is a hologram, then our perceptions are not direct experiences of reality, but filtered interpretations of encoded data. This means that much of what we take for granted, space, time, and matter, might be more fluid and interconnected than we ever imagined. As we peer deeper into the nature of reality, we must confront the possibility that our universe is not what it seems. The holographic principle opens the door to a new understanding of the cosmos, one where information and perception are intertwined in ways we are just beginning to explore. In this grand cosmic cinema, we are both the audience and the projectionists, interpreting and creating the reality we experience. It is a humbling and exhilarating realization, inviting us to look beyond the surface and question the very fabric of our existence. So how did we arrive at this mind-boggling idea? The journey begins with the mysterious and captivating study of black holes. The seeds of the holographic principle were sown in the study of black holes, those enigmatic cosmic objects where gravity is so strong that nothing, not even light, can escape their grasp. These celestial giants have fascinated scientists for decades. In the 1970s, physicist Stephen Hawking made a groundbreaking discovery. Black holes aren't entirely black after all. His work revolutionized our understanding of these cosmic phenomena. They emit a faint radiation now known as Hawking radiation, and this radiation carries away information about the black hole's contents. This discovery was both astonishing and perplexing. This presented a profound puzzle. If information can escape from a black hole, where does it go? The scientific community was abuzz with this paradox, leading to intense debates and discussions. And how can the information about a three-dimensional object, like a star that collapsed into a black hole, be encoded on the two-dimensional surface of the event horizon, the point of no return around a black hole? This question led to deeper inquiries into the nature of space and time. The holographic principle emerged as a possible solution to this paradox. It was a radical idea that suggested a new way of looking at the universe. It suggests that the information about the three-dimensional interior of a black hole is actually encoded on its two-dimensional surface, like a cosmic hologram. This concept was both revolutionary and controversial. This idea, once considered fringe science, has since gained traction among physicists as a potential bridge between quantum mechanics, the theory of the very small, and general relativity, Einstein's theory of gravity. The holographic principle could be the key to unifying these two pillars of modern physics. Section 5. The information paradox. Evidence in the event horizon. The idea that information about a three-dimensional object could be encoded on a two-dimensional surface might seem, well, counterintuitive. But there's a surprising parallel in our everyday world: digital photography. Think about a high-resolution digital photograph. It can capture an incredible amount of detail about a three-dimensional scene, encoding information about the shape, color, and texture of objects in the image. And all of this information is stored on a two-dimensional surface, your computer screen, or a printed photograph. Similarly, the holographic principle suggests that the universe might be like a giant cosmic photograph, with information about everything in it encoded on a distant two-dimensional surface. This surface, like the event horizon of a black hole, could be the ultimate limit of our universe, the boundary beyond which our laws of physics break down. If our universe is indeed a hologram, it would have profound implications for our understanding of reality. It would mean that everything we perceive as solid and real is ultimately an illusion, a projection from a deeper level of reality that we are only beginning to glimpse. It could also revolutionize our understanding of the universe's origins. Instead of arising from a singularity, as the Big Bang Theory suggests, our universe might have originated from a two-dimensional seed of information, a cosmic blueprint that unfolded into the three-dimensional reality we experience today. The idea of a holographic universe also has profound philosophical implications. If our reality is ultimately an information-based construct, it raises questions about the nature of consciousness, free will, and the very meaning of existence. Are we merely characters in a cosmic simulation? Are actions predetermined by the code that governs our holographic reality? Or is there something more, some spark of consciousness that transcends the limitations of our perceived reality? The holographic principle, while still a theoretical concept, offers a tantalizing glimpse into the potential nature of reality. It suggests that the universe is far stranger and more wondrous than we ever imagined, a place where information is paramount, and the boundaries between reality and illusion blur. It challenges us to question our assumptions about the world around us and to embrace the unknown. It encourages us to look beyond the surface of things, to seek the deeper patterns and connections that underlie the fabric of existence. Even if the holographic principle ultimately proves to be incorrect, the journey of exploration it has sparked has already enriched our understanding of the cosmos and our place within it. It has shown us the power of human curiosity, our innate desire to push the boundaries of knowledge and to explore the universe's deepest secrets. So what do you think? Is our universe a grand cosmic hologram, a projection from a deeper level of reality? It's a mind-bending idea, to be sure, but one that has captivated some of the brightest minds in physics and philosophy. Share your thoughts, questions, and wildest theories in the comments below. Let's explore the universe's mysteries together, one cosmic mind-bender at a time. And hey, Even if it turns out we're all just holograms, at least we're holograms with a sense of humor, right?